test like this, by the time you get to the end of the route, you're experiencing some pretty serious arc blow. It really helps. We're going to set it at the low end of the range for 532 78T, but the arc force will be set to 10. Arc force is a feature that senses your arc length, and when you get a tight arc length, your voltage drops and it'll bump the amperage up. The reason we're using 532 electrode for this video is not because that's the best choice. It's just what some people are being required to do. I've got some requests for this video. I would choose a 1/8 all the way out personally. Some people would choose a 232 for the root pass. That's just a personal preference thing. I would recommend anybody get a hold of the Lincoln consumable catalog, whether you're using Lincoln products or not. There's a lot of good data in there. That's where we found the range for 532 78T. I actually won't be using Lincoln electrodes in this video. I just bought 10 pounds off Amazon because I never need 532 7018. I didn't want to buy that many. So Andrew is using a little upside down V technique, but then switches gears here to just using a sort of a circular thing going counterclockwise there. I noticed while I was watching him do this, he switched this up 2 or 3 times and it didn't really seem to make a difference in the way it looked in the end. Both techniques work. It does seem to help kind of flatten the bead out to work it a little bit like this. What you really want to accomplish though is you want to burn in all the way to the backing strap and burn all the way through those corners there, to where when you're doing a bend test or whatever, you're not going to have any inclusions, any undercut, anything like that. Got to make a restart here, starting ahead of the crater by about 1 inch and coming back down in there, and then just working it and welding back over top of any arc strikes that are left. Got to really be careful on arc strikes on any welding test. It's grounds for failure if you have an arc strike outside of the weld zone. So you always want to make your arc strikes where you weld back over them. All right, root pass went in pretty good. Just slightly convex, nothing too drastic. It's going to be easy enough to penetrate on those toes for the next 2 beads. And the next 2 beads are going to go in really quick because the goal here is not to fill it too much. And the reason we're doing stringers here is because sometimes stringers are mandated. I would prefer to do a weave personally as far as just passing a test, but that's not part of the procedure sometimes. Sometimes weaves are not allowed, and there's a limit on how wide you can weave, and sometimes it's only 3 or 4 times the electrode diameter. So that bead went in there pretty quick, didn't deposit a whole lot of metal, and it left a nice little valley here. Not going to be hard to penetrate in there. You always got to plan 1 bead ahead on multi-pass welds and groove welds like this so that you don't pinch yourself off and leave a really deep valley. And that's going to be really easy to burn into right there. Now this one going a little bit slower because we left that little valley there. And the goal here is to leave a little bit of that edge of the bevel. Try to leave the straight line so that you can make a nice straight bead on the cover pass. And so here Andrew is just doing just a slight oscillation back and forth, keeping an eye on the right-hand side of that bead and trying to come over far enough on the left side to not leave any valleys or low places. So we're slightly below flush here, actually in really good shape for the cover pass, because the 532 is going to put down a pretty heavy bead, and a lot of times you're dealing with a 1/8 maximum cover pass height. So it's best to be a little bit low for the cover pass. All right, that's the first pass in there. And the second pass now, Andrew is really watching the right-hand side there to not leave any undercut, and on the left side of the bead trying to come as close to halfway on that bead as possible so that it's a fairly smooth transition from bead to bead. If you really watch, it's sort of a little upside down U motion that he's doing here. Trying to keep a fairly close arc, and that arc force being set to 10 allows him to keep a tight arc without the rod sticking. If you don't have arc force, my best advice, set the rod just hot enough to where the rod won't stick when you hold a tight arc, then hold a tight arc. That holds true for so many things when it comes to 7018 tests. Now for this video, we really didn't let it cool much. It was almost bead after bead after bead. So had to make a stop there, a couple inches from the very end on the last bead. You don't want to do that if you don't have to. But we're going to go ahead and let it cool down to about 150 before we run that last couple of inches. If you just camp out on it and never let it cool, you're going to have problems toward the end of these beads like this. Andrew is washing back and forth all the way to the end, filling it all the way up just for looks, to make sure it's welded end to end. No inspector wants to see you stop half-inch short. Even if they're discarding the ends, they don't want to see it. So you want to weld it end to end. All right, a quick wire brush here shows the cover pass. Not too shabby for 532. Again, the reinforcement or cap height requirement is generally 1/8 of an inch for AWS D1.1 tests like this. This is called a VWAC gauge. It'll measure undercut as well as height of cap, and it's in metric, but it's 2 millimeters. That's 80 thousandths roughly, so well within the 1/8 height requirement. Nice work, Andrew. Well, I hope that helps anybody having to take this test with a 532 rod. I also have some videos using a 1/8 rod. I'll link them up here and here. Thanks so much for watching. This video is brought to you by my online store at weldmonger.com. See you next time. Hey, Jody here with WeldingTipsAndTricks.com. One of the things I want to be doing more of is out-of-position welding, overhead, vertical uphill, 6G pipe, all that kind of stuff, because that's what helps people get to the point where that's what will help people pass a welding test. Passing a welding test is a big deal toward getting that paycheck, feeding your family. So today I'm going to be welding a plate, root pass in a plate, and the reason for that is mainly just to get the settings down, the gap and the land and the joint configuration and all that stuff dialed in, along with the amperage and or arc force depending on the machine, so that then that same setting will work on pipe, and then we'll do 6G pipe, 5G pipe later on. Today we've also got a tip on what to do when the keyhole gets too big. So before we get into that video with arc shots, tips and tricks, I want to talk a little bit about this weld test stand here. It's from Triangle Engineering. I was talking to them on the phone about ordering some plates and pipes, and they offered to let me use this thing for these videos, and it's going to come in really handy. Let me give you a little quick look at it here. I've got it temporarily bolted to a big stainless steel flange down there, and I've got some little leveling feet, and it's temporary. I'm going to be moving this thing to a whole different location here pretty soon, but I wanted to get something done with it. And it's got the little work surface there, a little miniature little table for working and grinding and whatnot. And so you can see those 2-inch Schedule 80 pieces there. I've got some things planned for those, some 6G tests for those. That's actually the first test I ever took, was a 6G 2-inch Schedule 80 6010 root 3/32 rod, and failed the crap out of it. So I need some practice before I do that video. Then here's the rest of it. Little shelf there for holding a grinder, chip and hammer, brush, things like that. And you can see this is the part that holds your pipe or plate, and it'll hold any pipe, any plate in any position at any height. And up top there's a brace that stiffens things up, and like I said, I'm going to move this thing to a different location, so I'm not going to worry about that just yet. And here's a picture from Triangle Engineering's website that shows you just how many different positions and how many different shapes and sizes this thing will hold. Okay. Time to weld. First thing is I've got to prep these things. They come saw cut like this. These are 7 inches long. They're 3/8 inch thick, 7 inches by 4 inches, and they have a 37.5 degree bevel on them. You can also order 22.5 for structural plate. This is for practice for pipe. So I'm going to stack them up here and go ahead and grind a 3/32. That's 2.4 millimeter land on these things. The land is this flat spot. Instead of having it go to a sharp point as it is with the saw cut, I need a little bit of land on there for putting the root pass in there with a 6010. And I clean it up a little bit and use a piece of wire to gap it with. I tried some of these with a 1/8 gap and 1/8 land, and I just wound up liking better the 3/32 gap, 3/32 land. Just using a piece of weld wire bent to get that gap in there. And I didn't really spend a lot of time cleaning these, because these are just practice joints, and really I'm just trying to get the right fit up, the right land, the right gap, and the right amperage.
Okay, this is set at 70 amps and it's too cold. You see, it's not ever keyholing. Just it's laying up top. Even though I've got it jammed in there pretty good, I don't hear it coming through the back side like I should. That's not going to get it right there. Now 80 amps, on the other hand, a bit hot. You can hear the difference in the sound. I'll shut up here for a minute. You hear it just kind of snorkeling through the backside, but it's kind of almost getting out of hand with me. The keyhole's just almost getting too big. 75 amps, just about right. It turned out just to be just a tad colder would have worked, but if the gap closes up on you, then might be too cold. So rather be just a tad hot than way too cold. So let's look at this. This is kind of like out of hand here. This is like it starts off okay, and then gradually it just starts getting like, oh crap, oh crap, oh crap, and I've got to really step out here, got to really move on, and the keyhole just kind of wants to get bigger and bigger and bigger, and then it's just kind of trying to bail if it does that, rather than just fighting it. So let's take a look at what you do when that happens. Like, that's why they call it a keyhole. It looks like an old-timey keyhole in a door, right? But that keyhole is just a little bit on the large side. So what I would recommend here, this is just one recommendation by the way, is to, instead of starting back in that keyhole, start right above it. And I didn't get a hot enough start there like I had hoped, so I'll have to fix that with a grinder a little bit. But just start right above it instead of back into the keyhole, if the keyhole's too big. And then just keep welding, and then come back later with the grinder. You see, I've got the hole there that I didn't close up. Come back later with a grinder and feather it out, taper it out just about like that, where it's really, really thin, and then long arc it when you light up. Long arc it, preheat it up, and go in there and jam it in there. Make tiny little circles, and then kind of push that hole upward. Just keep pushing it, moving the hole upward until it closes up, and then go another several strokes, and then whip down. And that's the backside right there. Okay, what I would prefer to do though, if the keyhole is not getting out of hand, I prefer to just keep another rod in my hand or handy and put it in the stinger and get right back in there while everything's still good and hot. Just long arc it for just about a second and then go right back into that keyhole. That works good for me. But you can't always get right back in there, and so sometimes you just have to stop and maybe get a grinder out and feather, taper a little bit. But once again, got to keep that thing jammed in there. You want to hear it coming through the backside, tight arc. And it's almost like you're just tapping a little tiny nail with a little tiny hammer in and out of that puddle. Tap, 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 tap. One way of looking at it anyway. Okay, well that was the root pass. Let me give you a little refresher here. Again, this is the technique for the root pass. It's almost feels like you're scooping out metal sometimes ahead of you and then coming back, jamming it in there into the puddle, and then just kind of coaxing that thing forward with you. This is uphill, like I said. Now, after grinding the root pass a little bit, getting the slag out of there, not completely slick. I never have really been a fan of grinding a root pass till it's just completely slick, because you take out a lot of metal and you can blow a hole. But this is 7018 now, and actually trying to fill it flush with one pass. That was one idea, and I'm really having to go slow to do it. So then I changed gears, decided I'd put two passes in there instead of one to fill it up. So this one I'm just kind of moving kind of a little quicker, not coming out as wide onto the sidewalls, and then coming out with another pass to fill it out flush. And you want to be just flush or slightly below flush, not above flush at all. And that'll give you nice straight lines on the sides to stay straight on your cover pass. See, I'm just a little below flush there, and that's going to be okay. You don't want to be too far below flush, or it's too hard to fill it up without undercut. And speaking of undercut, you want to hold your toes. You want to hold those edges for just a good, maybe a full second actually sometimes, to avoid undercut, or if you got a little bit of a low place, it just gives it a chance to fill it in, and that's that. I'll be showing this thing along the way in future videos, doing different positions, but I just did want to show Triangle Engineering a little appreciation for letting me use it in these videos. Well, that about wraps it up. Don't forget to hit the subscribe button, hit that thumbs up button if you like what you see. Visit the store and check out those high visibility t-shirts. We'll see you next week.